Hello, students. This is Mr. Allen, your geometry teacher. Today we're going to finish up Chapter 2, which is on deductive reasoning, and we're going to look at proving angles are congruent. Our only objective today is to prove and apply theorems about angles. So our first theorem here is called the vertical angle theorem, and it says the following. If angles are vertical, then they are congruent. So for example, angle 1 and angle 3, those are vertical angles. Therefore, they are congruent. Vertical angles are congruent. Let's say we wanted to prove this theorem. How would we prove the vertical angle theorem? Well, the given, remember we could break this into an if-then statement. We could say if angles 1 and 3 are vertical angles, comma, then the conclusion they are congruent. So we're going to go ahead and start with that. The given is that angle 1 and 3 are vertical angles, so that's given. Now notice what's true about angle 1 and angle 2. Similarly, what's true about angles 2 and angles 3. So that's our second statement. Our second statement here is that angles 1 and 2 are supplementary and angles 2 and 3 are supplementary because they both form linear pairs and linear pairs are supplementary. Now, if angles 1 and 2 are supplementary, what does that tell us? Supplementary means that the angles add up to 180. So from step 2, we can now go to step 3 and say, okay, the measure of angle 1 plus the measure of angle 2 equals 180. The measure of angle 2 plus the measure of angle 3. Now, I'm doing two things in each of these statements because we're doing the same thing. The reason for this step is the definition of supplementary angles. Now, you can literally write out the definition, which is what I did here. Or if you don't want to write it all out, you can just simply write definition of supplementary angles. So I'm abbreviating it right there. Now, this next step here, we see that measure of angle 1 plus measure of angle 2 equals 180. Measure of angle 2 plus measure of angle 3 equals 180. So that means that these two guys have to be equal. And that's by the transitive property, or you could use what we call substitution. Okay? Since they're both equal to 180, that means they have to be equal to each other. Now notice that on both sides of the equation, we got the same amount, which is the measure of angle 2. So step 5, we can just subtract those away, which gives us that the measure of angle 1 is equal to the measure of angle 3 by the subtraction property of equality. And then, of course, if those two angles have the same measure, we call those congruent. That is the definition of congruent angles. Okay? So there's our 6-step proof, which proves that this theorem is true, which means since it's proven true, it's always true. Now, a quick review of some of the vocabulary from the past. We have here adjacent angles. We notice here that angle 1 and angle 2 are adjacent angles. Oops, and I put angle 3 and angle 3. That should be angle 2 and angle 3. Let's just change that. Let's call it angle 3 and angle 4. How about that? Angle 3 and angle 4. So angle 3 and angle 4 are also adjacent. And if you don't remember what the definition is of adjacent angles, it's right above here. So two coplanar angles that share a side and a vertex but no common interior points. All right, complementary angles. These are two angles whose measures have a sum of 90 degrees. So here would be an example of complementary angles. Angles 1 and 2 are complementary. This 50-degree angle and that 40-degree angle add up to 90. So those are complementary angles. Supplementary angles, well, those add up to 180 degrees. So here would be an example of supplementary angles, angles 3 and 4, or these two angles here, a 75-degree angle and a 105-degree angle. So what would be an example of some complementary angles? We look at our diagram, that means two angles that add up to 90, right? So I think angle 2 and angle 3, those two guys, those have got to be complementary. How about supplementary angles? Well, one answer is angle 3 and angle 4. So I'm just reviewing some of these angle names. Vertical angles. I think angle 3 and angle 5. And I think that's the only example in this one. Supplementary, there were some other ones. And then adjacent angles, there's a whole bunch of them. I'm just going to say angle 1 and angle 2. Those are adjacent. And again, there's more than one answer on some of these. Okay, so making conclusions. So there are some times when you can simply look at a picture and you can draw a conclusion. So for example, if you have a diagram and you see that angles are adjacent, you can conclude that they are adjacent. Same thing for supplementary angles, and the same thing for vertical angles. For those three things, you can simply look at the diagram and you can conclude those things. Unless the markings give you this information, you cannot, this is what I really want you to emphasize, these are the ones you cannot assume. You cannot assume that angles or segments are congruent. If they look like they're congruent, they might be congruent, but you cannot assume that they are. You cannot assume an angle is a right angle unless it has that little box shape. You also cannot assume that lines are parallel or perpendicular without some sort of extra notation or markings. Okay, so now I'm going to go through the rest of the theorems of this section. Theorem 2.1, we've already seen. Theorem 2.2, this is called the congruent supplements theorem. I'm going to prove this one in a minute, but here's what it says. If angle 3 and angle 1 are supplementary, and angle 3 and angle 2 are supplementary, then you can conclude angle 1 is congruent to angle 2. And like I said, I'm going to do that in just a minute. Theorem 2.3 is congruent complements theorem. This is the exact same thing as congruent supplements theorem, but it's about complements. And theorem 2.4, this one says that all right angles are congruent. So if angle 1 is a right angle and angle 2 is a right angle, we can conclude that they are congruent angles. Angle 1 and angle 2 are congruent. All right. Oh, I forgot about this one. This is 2.5. If two angles are congruent and supplementary, then they have to form a right. They each are right angles. So this is theorem 2.5. So if I told you that angle 1 and angle 2 are congruent, and I told you that angles 1 and angle 2 are supplementary, then those two angles have to each measure 90, which kind of makes sense. If basically we're saying both the angles have the same measure and they add up to 180. Therefore, they both got to be 90. All of these theorems can be proven using deductive reasoning, and I'm going to do that right now. So let's go ahead and prove theorem 2.3. So here's our given information, and here's what we're trying to prove. We know that angle 1 and 3 are supplementary. That was given, so the reason here is given. Okay, now, if angle 1 and angle 3 are supplementary, then that means the measure of angle 1 plus the measure of angle 3 equals 180. Similarly, I could say that the measure of angle 2 plus the measure of angle 3 is 180. Okay, so now I'm writing this proof from scratch. So if they're supplementary, it implies that they add up to 180 because that's the definition of supplementary angles. And I'm going to abbreviate here because I don't have enough room. Okay, now I'm writing this proof from scratch. Okay, this actually kind of looks similar to that proof we did earlier. So if angles 1 and 3 add, okay, good. So now, do you remember what happened earlier? Since they're both equal to 180, then that means they're equal to each other. So that means that the measure of angle 1 plus the measure of angle 3 has to equal the measure of angle 2 plus the measure of angle 3. I ran a little bit over there. So the reason for 3, remember when I mentioned this earlier, this is the substitution property. Substitution property of equality says that you can add equal things. You can, if two things are equal, then you can substitute them wherever. So this is equal to 180. Measure of angle 1 plus measure of angle 3 is 180. The measure of angle 2 plus measure of angle 3 is 180. Therefore, those guys are equal. Now notice that on both sides we have the same amount, and that's the measure of angle 3. So I can subtract that away on both sides. So step 4, I can say that the measure of angle 1 is equal to the measure of angle 2. That's by the subtraction property of equality. You can just say subtraction property. And then, of course, if the two measures of the angles are equal, guess what we call that? When the angle measures are equal, we call them congruent. Here's that fancy symbol. And so that is by the definition of congruent angles. Now, guys, I'm using a little bit of notation here. So a little bit of, I guess I should say, no, not notation, some abbreviations here to kind of squeeze this in, and I'm completely fine with that. So what I've tried to do here is model for you notation here on the left and then some abbreviations on the right. For example, this means angles. This obviously means congruent. This means equal. This is the substitution property down the line. So here's a lesson check for you if you want to pause the video and try to figure these out. Question 1, you're asked to find the measures of angles 1, 2, and 3 using these properties that we just talked about, theorems. And then question 2 there is a multiple choice question. But I'm going to go ahead and stop here and call it a day. So thanks for your attention.